So in this problem, we're given a function of f, which is a function of x and y, and we're supposed to find all of the partial second derivatives. To this, you always start by finding just your first partial derivatives. So let's find the partial of f with respect to x. So this means look at it, take your derivatives like normal, but y is just a constant, so we don't really care about y. We only care about x. So derivative of x to the fourth would be 4x cubed, and we still keep it times y, just like we would if it was any other number. And 4xy cubed, it would be 4 times the derivative of x is 1, times again we keep that y cubed there because it's just like a derivative. So just 4x cubed y plus 4y cubed. Okay, and we'll find the partial of f with respect to y. So exact same thing, but now y is the one we care about. So x to the fourth y, the derivative of y will just be 1. So we'll just have x to the fourth times 1. Plus this 4x, well those are just constants, we just leave them there. And y to the third, the derivative of that is 3y squared. So we get x to the fourth plus 12x y squared. Now that we found our first partial derivatives, let's find our second derivatives. So we write these as this little like partial symbol squared f. Let's do our x squared one first. Now this is x squared, but really it just means you're going to take the partial derivative with respect to x twice. So this means come back up to the x one and take it again with respect to x. So now we care about x again. So we'll have 4 times the derivative of x cubed is 3x squared. And keep the y there just like any other number, like we kept the 4 there. Plus the derivative of 4y cubed, well we only care about x's, so that's just 0. So we get 12x squared y. Okay, let's delete that. Now let's try, and it doesn't matter what order you do these in as long as you put the right one in each slot when you enter it in. Let's try the y one. So now let's go to the derivative of y and then take the derivative with y with respect to y again. So now we only care about y. So x to the fourth, we don't care about that. That's just a 0. Let's see, 12 will stay there. The x will stay there. And y squared, the derivative of that is 2y. So we get 24xy. Okay. Now the mixed partial derivatives. So the second partial, but this one says partial x, partial y. So these ones are the ones you actually have to remember which one you do first. So this means do the y first, and then x. Okay, so the reason why is these are considered like operations, and so it's really like it's trying to tell you take the derivative with respect, so it's like you're writing it like this. And so we just kind of combine it all together. And so you kind of do the inside first because you take the derivative with respect to y and then you take the derivative with respect to x. But whether or not you actually remember that, just remember you work from the inside out on this symbol. This symbol means do the y first and then the x. So we're going to have to zoom out a bit so we can actually see what our work is. So do the one with y first. That means come up and look at this one. So y first. Now take the derivative with respect to x, and we only care about x's. So x to the fourth, that will be 4x cubed. Plus, and now 12xy to the second, we only care about the x's. So the 12 still is there. Derivative of x is 1, and y squared stays there as before. We don't do anything to change that. And our very last one is the second mixed partial. And we'll do x first and then y. This means x first, then y, because you work from the inside out. So let's come all the way back up and look at our x's, which is this one. Okay, now we want to do with respect to y. So with respect to y, this derivative of y will be a 1. So we'll have 4x cubed times 1. And 4y cubed, we'll bring down the 3, so 12y squared. So let's go write that down. So this is going to be 4x cubed times 1 plus 12y squared. Now you'll notice that these two match, and that will always happen for nice, simple kinds of functions that we do in this class. There are more complicated functions, and that's not true, but everything in this class, they'll just always match.